In this video, I'm going to go over some of the code that I've developed in order to make changes against Brownfield devices. So I believe in actually, let me go and show you some of the changes that I did in the lab. So this diagram was in a previous video, but I added a lab router and a lab switch down here at the Kansas City location. And the reason being is what I would like to do, I'd like to test changes against these lab devices prior to deploying them to production. Now, in this particular video, we're not going to go into that process. I will show you some config changes, automated config changes on the production devices. But as I get further along into this and start getting more and more into the CI/CD pipeline and the pre-test and the post-test and things like that, I'm going to incorporate in the process these lab devices. So let me go to the code, and my IDE of choice is PyCharm. You can use anything you like, VS Code, whatever you find more comfortable. You can use whatever you want. So all this code, this entire NetDevOps Brownfield sites will be on my public Git repo. I will have a link in the description I will have a link to that Git repo in the description of this video. So let me just go over this, and this is just going to be a very high level. I'm not here to train anyone on Python and teach anyone Python code or any of these libraries or anything like that. This is just going to be a show and tell. I highly recommend that for those that are interested in this, to make sure that you do learn Python. There's a lot of courses out there on Udemy, sites like that. There's also some courses by Kirk Byers. He has a Python for network engineers. He has a free course, I believe, and then he has some paid courses. He also provides courses for Ansible and the Nornir framework. In this particular code that I'm using, I am using the Nornir framework for the automation for this lab environment. So let me go over a few things here. So I think one of the first things I want to go over is the directory structure that I have here on the left here. So one of the things that's important for this is that we have a remediation config changes directory, we have a rendered configs, and we have a running configs. Those are three directories that are required for this code this framework that I developed. So what it happens here, so if I look at the Brownfield config changes, I'm using Nornir, and again, I'm not going to go through all the details of Nornir or anything like that. But Nornir is really what I would call a Pythonic version of Ansible. It's much faster, it's much more flexible in my opinion, because it's using a true programming environment. It uses Python as opposed to Ansible, which is a domain-specific language, a DSL. When you get into environments that are not what I would call cookie cutter, every site is different. It may have a little nuance here and there. If you have a lot of logic flows and logic decisions in your automation because of those differences between locations, different sites and things like that, then the ability to do logic decisions in Python is a lot easier than it is in Ansible. Now, if you have a environment that every site is templatized, everything looks and feels the same at every site, then Ansible is probably a very good starting point. But again, I would still argue that Nornir is probably going to be, at least in my opinion, a better solution. But Ansible is a lot more ubiquitous out there in the network engineering space. So in any event, I created as part of this little framework that I created here, I created a net auto helpers module here. And these are just helper functions to do things, just basic stuff, delete directory contents. And what this will do, the Brownfield config changes, the first thing it does is it deletes the directory contents. I'm importing that net helper module as nh right here. So you'll see nh dot and then the function name. So I'm deleting the directory contents of this remediation config changes, rendered configs, and running configs here. I don't think they're not empty now, because I prior to the video I ran some stuff against the lab devices, as you can see there. So what the first thing it does is it deletes the directory contents of those directories. Like I said, we init a Nornir object, and you can do filtering and things like that on different names. Again, I don't really want to get into Nornir too much here. If you want a separate video, I can just let me know in the comments. I can go into what, the hosts file, the groups file, and the defaults, what all this means and how it kind of works with the Jinja templates and things of that nature, which I'll show in just a little bit here. Okay, so it initiates, or it initializes a Nornir object, and basically all I'm just doing Nornir runs against different helper functions that I have in the helper file. I'll go over that in just a minute. But the first thing it does, it goes out and it saves the running config of the device. So it SSHs into the device, and it takes that config and stores it into the running config file. So you can see in the lab router config here, I have the full config for the lab router. So it takes the whole config and saves it to file. And the second thing I do is I render the config, and what that does is it takes the Jinja templates that I have here. I'll go over that in just a few minutes. It takes that and it creates configurations based on the Jinja templates and from the inventory, from the Nornir inventory, and it stores it in a inventory, the object inventory data element. So Nornir has an inventory and of all the devices, and each device you can add data to the actual inventory object itself. So it takes that rendered config and stores it within that object. The next thing I do is I take that rendered config and I save it to a file in the rendered configs file. So just to kind of show you what that looks like for the lab router, it goes in here and it just outputs the config that I want to push to the device. Okay. And the next thing I do is I render a remediation config. I'm using the hierarchical config or higher config library for that. And then it deploys that remediation config to the device. And if there's any failed hosts, it will list failed hosts. So just as an example here, let me go in and let me run this Brownfield config changes real quick. Make sure there's no issues. And so it's going to go against all of the inventory, all these devices here. It's going to go and do its thing. There's a lot of output here. I'm basically, after each task, after each Nornir run, I'm printing the results of each run. So there's a lot of things here. Okay, so no failed hosts, so everything worked fine. So let's do something here. Let's test something. Where's my filter? Let me filter this on, and I just want to do one device, be easier to show, I think. So let me Just run this real quick, make sure the filter is working right against just the lab router 01. Let it finish up here. Okay, so you'll see that, okay, so the lab router 1 is what's remaining here. So this is what was pushed to the device, the remediation config. Okay, so I'll explain my thought process around this loopback 1000 in just a little bit, but let's go to lab router 01 and let's go take a look at that real quick, and then let me make a change, and let's make sure that the change is, opened it twice, didn't mean to do that. Okay, so let me go in here in lab router 1, password 123. Okay, so let's go look at the NTP. So let's go here and, can't type. Let's go in here and let's add an NTP server. NTP server, let's just say 1111, right? Let's just make sure that 111 is there. Okay, so 111 is right here. So what I want as part of this, I want to make sure that the NTP servers are, the only ones listed are going to be the 24.1111 and the 24.1112. And let's say another engineer, for whatever reason, went in here and added NTP server 1111, and that makes the config out of compliance at that point, right? So let's run this against, let's run this Brownfield config changes against this lab router 01, and let's see if it removes NTP server 1111, which it should. So let me run the Brownfield config changes, and the filter here in the Nornir filter, I'm only filtering against, I'm only running this against the lab router 01. So let me run the config. Make sure this works. It has to go through all of its steps. All the steps I talked about earlier. Okay, so now it's done. So let's go look to see, and you can see that the it was configured. I gotta work on this unexpected end of configuration file. I just need to add an end to the end of it, I think. I'll play with that later, but it saved the config. So let's go look at, let me just up arrow and look at NTP. Hopefully the 1111 is gone. And it is. It took out that erroneous 1111 that another engineer went in and configured on their own manually, like they should not do in an automated environment. So let's go make another change. Let's see what happens. So one of the other things that I'm automating is SNMP. So let's say that instead of an extra, let's say I am missing a couple things. So let's just remove, these three here, the ones that start with config on them. I'm having a hard time copy and pasting. Let me just, excuse me, I have to manually type this. Remove that. Let's remove the second line, and then remove the CTID. I don't know what that is, but let's save that to memory, or save it to the startup config rather. So let's just go back to the SNMP portion. And there should not be any SNMP traps enable or anything config related. I don't see it, so it's not there. So now let's go and rerun this script, the Brownfield config changes script. Okay, so let's go take a look at it. And I'll just do SNMP server include, make sure the 3 lines are there for config, and look, they're there. So it remediated the config to the intended config. That hierarchical config library from I believe Network to Code is sponsors that, or actually did that library. It's a phenomenal piece of software. It's really great. It does a really good job. I did have, let me just go through here and show you one more thing. So another piece of the thing I'm automating is this access list. If I can find it. This access list here, standard management server. So let me okay, so let me go in here. And let's just do a permit. I'll just do a 1111 and a permit 2222. And if I look at that access list, I should have 3 entries now. Okay, here it is right here. So what happens is, or rather, I'm sorry, the permit 10.10.10.10 is what I want as the standard. Anything else is just erroneous. So I need to make sure that the remediation config removes these permits. And so let me run this. I did have a couple of things. It was an odd issue. I had to run twice, but in a test, but I couldn't recreate that issue. Let's see if it happens here. So let's go look at that access. I typed that right. There we go. So the only thing left is that 10.10.10.10. So it worked great. So it works with nested or parent-child relationship configurations, if you will. You can even set this set something in. When you set something out of order, when you do a show IP access or show access list management server, you can see there's that 10 in front of it. So if I were to go in here, put something in front of it, like this, if I do a 5 permit 1111, so now when I look at that, but when I actually put it, okay, when I did that show run, it was when I did the show access list. Let's take a look. So it had the 5 before. Okay, so even when you do something like this, it should remove the 1111. Let's save this and let's rerun this, make sure that 111 is gone. There's a command to reorder that access list in the running config, and I forgot what it is off the top of my head, but it shouldn't matter. This might have been where the issue that I saw before. So it's still there, right? So it ran, and I gotta figure that out. And if I run it again, for some reason, I think it takes it out the second time. No, it didn't either. It's looking for that 20. I need to reach out and figure out what's going on there. But that's not that big of a deal. Yeah, that's interesting. I need to reach out maybe to Network to Code on their Slack channel and find out what's going on here. Maybe they have some recommendations. But anyway, so for all intents and purposes, this is a good tool, and it will make sure that everything that you specify as standard configuration, as intended configuration, will indeed be pushed, and the appropriate commands will be pushed to make sure that it meets the intended config. Now, to kind of go off a little bit in how these intended configs, these rendered configs are created, like this, for example. This is a render config from a Jinja template. And so what happens is you have routers and switches in the lab, and each one, and I'll just show you real quick. In the Nornir inventory and hosts, I have iOS WAN routers and iOS LAN switches as two different groups. iOS WAN routers and iOS LAN switches. And that is how in the templates, when I call the template in the actual helper file itself, I'm kind of getting off into the weeds here, but when I render the config, where is the function? Render config. Yes. So if it's an iOS LAN switch, it's going to use the switch's base config template. Otherwise, which in this case, if it's not a switch, it's going to be a router in this particular environment, then it's going to use the router base config template. So if I look at the templates, let's just go through one. Let's just go through the router, the base config, and you can see I have commands here that go into the Jinja template, or actually these Jinja templates have commands, and then you have variables here. These variables are actually pulled from the Nornir inventory. So if I look at, and this, I'm in the router template here for the base config. So what it would do, let's say this is running against a lab router 01, which is indeed, if I look at lab router 01, it's an iOS WAN routers. So if I look at the group iOS WAN routers, I have iOS, and then I have, it's part of the, one second here, I'm confusing myself. Oh, it's also part of the lab router is also part of the lab group. And so if I look at the group here under lab, the data, you'll see that I have time zone CST right here. And so that's where the Jinja template pulls that variable from. So the time zone, and then the time zone offset is the -6. So whenever it generates the config for a clock time zone, it should say CST -6 and then 0. So if I look at the rendered config, you'll see indeed it does show CST -6. All right, so where was I? Okay, and then it pulls in all this, this other information, and it applies. This is just solid text. There's no variables here, but then it includes the router's SNMP Jinja template. So right here in the routers SNMP, and then it pulls all this information here. there's the management server IP, which it will pull from maybe in the host file. Nope, I'm sorry. iOS WAN routers, groups, maybe defaults. Yes, that's the default for everything. The management server IP is 10.10.10.10. And that's where the Jinja template pulls that from. The city name, SNP string. All of this is part of that inventory. And then it essentially just creates the text files based off these variables. And that's what it uses to build the rendered configuration. So eventually I would like to see where a whole config, an actual start, from the top down, a full config is templatized. I've done that before in on a production environment, and it works well. So I think what I want to do now is just explain one thing that I think I talked about briefly, and I don't think and it's not really that important to do, but you'll notice, for example, I'm looking at the remediation config changes here, and you'll notice that I have a loopback 1000, and it has this hex value, and this is basically a UUID that I automatically create. And the reason I do this is that I want to make sure that the rendered config that I push to the device here is the same as, excuse me, I want to make sure that the config I push to the device is the same as what is running on the device. So the way I can check this was from the last run. I can say, okay, this is the remediation config that was pushed. Here is the loopback 1000 description. And so what I can do, I can go and take a look at show run interface loopback 1000, and I can see the description here, and it ends in 97 Charlie 2, ends in 97 Charlie 2. So I know that the running config is actually running the remediation config change that we pushed. Okay, so that's a way to verify, and it's also, it makes it easy to, and I don't want to go into it right now, but I've created a whole bunch of Python PyTests, and it checks for that. It makes sure that the rendered config description for loopback 1000 is the same as the running config for loopback 1000, the description on that. So it's just a way to sanity check to make sure that it is indeed the same. And every time I run this, this UUID is automatically, it's a random UUID. It's created, and it changes every time. So it won't be the same from previous runs. So that's an easy way to logic check the config pushed versus what actually exists on the device config. So I think I'm going to end the video now. But I would encourage everyone to, if you're interested, take a look at this module I created, the helpers. This is basically the logic that I'm calling. In the very beginning, I talked about did I close it? No. All of these nor near tasks that I'm running here are all from this helper file here. And the entry point into the helpers, I created, and this may or may not be best practice, but I wanted to kind of keep the actual functions that actually do the work as as private. The render configs, the write configs, the save running configs, all that, and I just wanted to have the user be able to access, from a dispatch perspective, to just call these nor save running, because eventually, this could be expanded to be not nor, it could be napalm, it could be netmiko save running config to file, and it would just be an easy way for someone to call that, and then this function calls the other function to do the actual work. So that's the way I set it up. Right, wrong, or indifferent, I'm not sure. So yeah, so I think that's it for now. I think this is a good place to stop, and I do want to go over eventually these PyTests that I created that test the environment. I started learning a little bit about test-driven development and what it means, and so I bought a book and on PyTest and learned quite a bit, and I think it's very beneficial to be able to test changes against, for example, in this particular case, test changes against these lab devices before you push it to production. And PyTest lets you do that. It lets you write the tests, set up the environment, set up the test the way you want to, and then make sure that the result is what you expect. So, it does functional tests, unit tests, a whole bunch of different things. And from a CI/CD pipeline perspective, you definitely want to, when you make a change to code, you want to make sure that you have the ability to test against a test environment prior to pushing to production. So we will hopefully get into that in later videos. All right. Thank you for watching.